Guys, so in this video, I want to talk about a natural log constant, a natural constant or natural number or in exponential. Okay. So this is the usual definition for E. If you learn about calculus, just limit 1 plus 1 over n to the power n. And why I want to ask is, does E really exist? Because in the calculus, that people always say, oh, this is the definition for E, then blah blah blah, and you can do the following calculus, do derivative, L'Hopital rule, and when you go to the second grade, then you start solving the ordinary differential equation and blah blah blah. Okay, but does E really exist? I mean, is limit n to the infinity 1 over 1 plus 1 over n to n really exist? So the answer definitely is yes, right? The answer must be yes. But how? Okay, how do you show this limit? Definitely exist. Okay, and some guy will say that, oh, you can. Okay, some guy will say that, oh, you can take log, take 1 over n, take log, and use the L'Hopital rule. Basically, this is the somehow like the illegal way, right? Because without E, then we cannot just easily define the log, the derivative for a log. So we cannot just do this. So this is the illegal way. So in this video, what I want to show is that E really exists. It means that I will show this limit exists. Okay, so how to prove the limit always exists? So I can write this as an. Okay, so what we want to show is that an increase. So that means an plus 1 larger than an, and we will show that an is also bounded. So from the continuity, or basically the complete properties of this, series, then we can show that the an must exist. So basically, once we prove this, then the rest is just follow the real number has a complete property. Okay, so basically any Cauchy sequence will converge in the real space, in the real line. Okay, so what we need to show is an increase, and the an is also bounded. Okay, so the proof. Okay, so first one, an is bounded. Okay, this is really trivial. That I don't know how you guys will show this, but how I show this, I just use the binomial coefficient. Okay, so I should use this notation. Okay, and so the first one is 1, the second one is 1, the third one is n minus 1 to n squared, and then n minus 1, n minus cube 2 and 3, keep going, and the final is this one. Okay, so I want to show that which is bounded. So how I can show? I can say 1 plus 1. How about this? How do I? Okay, so I just want to replace into half, right? Because n, so this is less than n squared minus 2n squared. Okay. Oh, sorry, this is 3 factorial. Okay, so I want to less than 1 3 factorial, and then 1 keep going. Okay, now I can show this, right? Because n, basically from this one, you can obviously see that n to the n is larger than n to the factorial. So this is the obvious upper bound for this. So this is 2 plus half times 3 factorial times 4 factorial plus n factorial, which is less than 2 plus 1 over 2 plus, this is 6, right? 3. I can write it 3 over 2, and this is 4 times 3 times 3, 4 times 3 times 2 times 1. So which is definitely less than 1 divided by 4 times 3. And this is less than n minus 1. Okay, so this is 2 plus half times half minus 1 over 3, 1 over 3 minus 1 over 4. This is this term, and then keep going, you get 1 minus n minus 1 minus n. So you can cancel it. So finally you get this one. You get this an must be less than 3 minus 1 over n. So which tell you that an is bounded by 3. Okay, so an is bounded, an is bounded. Okay. Okay, so second, what we want to show is that an increase. Okay, so an is defined to be this. So what I want to show is an plus 1 larger than an, which tell you that the e1 plus 1 divided by n plus 1 to the n plus 1 power is larger than 1 plus 1 over n to the n. Okay. And in order to do this, what we need is the a arithmetic mean will larger than geometrical mean. So basically, I have other videos prove this identity, and you can go to check it. Suppose, so the identity means that suppose you have inequality means that suppose you have a1 to an numbers, and you can add it. This is the arithmetic mean will larger than if you times all of this divided by 1 over n. This is called the geometrical mean. Okay. So we can use this on n plus 1 number. Okay, so what we have is 1 over n, 1 over n, 1 over n, 1 over n plus 1 over n plus 1. So we have n of them, right, divided by n plus 1, we're larger than times of this. So we have this to the 1 over n plus 1 power. Okay. So we have 1 plus 1 over n plus 1, n plus 1, we're larger than 1 over n, 1 over n plus 1, 1 over n plus 1, 1 over n plus 1. Okay, so be careful that the computation is somewhat tedious. Okay. So basically, we combine this. I usually don't like this color. How about we change to blue? So we have this one. We're larger than, okay, so you times this n plus 1 to the rest. So all you get is n plus 1. This is 1 minus n plus 1. 1 minus 1 divided by n plus 1. So this is right. Okay, so we can times n to the n plus 1 power to both sides. So we have this. We're larger than n plus 1 n, 1 over n. Okay, so this is 1 plus 1 over divided by n plus 1 larger than 1 over n to n. So this tells you that an plus 1 really larger than an. Okay, so fortunately we prove an increase, and an is bounded. So the answer is E is really E really exists. Okay, so a large work. Okay, and be sure to subscribe to my channel if you think this is helpful. And I also did high school math to graduate math, and I hope you guys enjoy this video, and I will see you guys in the next video.